Hey there and welcome. Every single day, we're sending just a mind-boggling amount of information across the internet. But if you ever stop to wonder what's actually happening behind the screen, well, today we're going to pull back the curtain and follow the incredible, invisible adventure our data takes every single time we click. It seems like a pretty simple question, right? But the answer? Oh, the answer is this amazing story of speed, of logic, and of this massive global infrastructure. We're going to follow one tiny piece of data right from your screen all the way across the world and back again. And it all happens in just a few milliseconds. It's wild.
All right, so our story kicks off the very moment you do anything online. Doesn't matter if you're sending a quick message or loading up your favorite website. The absolute first thing that happens is the creation of our story's hero, the network packet. The best way to think about it is like this. Instead of trying to mail a giant 1,000-page book all at once, you mail it page by page. That's exactly what a packet is. It's just a small, manageable chunk of your data, and it's all neatly wrapped up in this digital envelope so it knows exactly where it's supposed to go.
Okay, so on that digital envelope, you've got this crucial address label, and it has four key parts. You've got the source IP, that's your address. The destination IP, that's where it's headed. Then there's the protocol, which is basically the set of rules for how to handle the delivery. And finally, the payload. That's the good stuff, the actual piece of your data.
So our little packet is all packed up and addressed, ready to go. But its very first challenge, just getting out of your house. It's got to navigate your local home network first. Before it can hit the wild world of the internet, every single packet has to pass through the traffic director of your home, your router. You know that little box with all the blinking lights? It's what's known as the default gateway. It manages all the conversations between your phone, your laptop, your smart TV, and makes sure they all get a turn to talk to the outside world. But wait, how does your router keep all those devices straight? I mean, how does it not get confused? Well, it uses something called DHCP. Think of it as an automatic numbering system. The second a device connects to your Wi-Fi, DHCP hands it a unique private address, something like 192.168.0.10, so there are no mix-ups or arguments about who's who on your network. Okay, now this is where things get really clever. You might have 10, maybe 20 devices at home, right? Each one has its own private address. But your internet service provider, your ISP, usually only gives you one single public IP address to face the world with. So, how on earth does that work? The solution is this brilliant process called network address translation, or NAT for short. Your router basically becomes this super smart receptionist. It takes all the requests from all your different devices and sends them out to the internet under that one single public address, all while keeping a perfect little log of who asked for what. So let's break that down. A packet starts its journey with your laptop's private address. As it passes through the router, NAT literally rewrites the from address to your single public IP. Then, when a response comes back from the internet, the router looks at its log, remembers which device made the original request, and translates the address back. And here's a cool bonus. This process also acts as a basic firewall, since it keeps your individual devices hidden from the public internet. All right, our packet made it out of the house. It's now officially on the open road, the global internet superhighway. We're talking about a vast, ridiculously complex network of connections that spans the entire planet. So how does a tiny little packet find its way through this insane maze? Well, it has a guide. It's called BGP, the Border Gateway Protocol. And you can totally think of it as the GPS for the internet. It's the system that all the major routers use to constantly talk to each other, sharing updates on the best, fastest, most efficient paths to get data from absolutely anywhere to anywhere else. And so the journey begins. The packet leaves your router, jumps onto your ISP's network, and then starts hopping between these massive, powerful routers. Each hop is just a stop at another router that looks at the destination address and says, okay, you need to go that way, and sends it along the best path. This journey can cross cities, oceans, and entire continents in the blink of an eye.
And believe it or not, this isn't some abstract concept. You can literally watch this happen. There's a command called traceroute that lets you follow these hops. So, for example, a packet might start out in Tokyo, hop to a huge internet exchange in Seoul, zip across the Pacific Ocean to Los Angeles, and then finally enter Google's private network in Mountain View to reach its destination. It's so cool.
And it's arrived. Our packet has braved the global superhighway and reached its destination. But hold on. The mission is only half complete. Now we have to see what happens next.
So the server at the other end, let's say it's at YouTube's data center, it gets the packet. Its systems immediately unwrap that digital envelope, read the payload inside, which might be your request to watch a cat video, and it gets right to work preparing a response. And that response, of course, is going to be a whole new set of packets heading back your way.
You know, this whole process, both sending and receiving, it works like a perfectly choreographed relay race. Each layer has one specific job. The application layer creates the request, the transport layer breaks it into chunks, the network layer slaps on the address, all the way down to the physical layer, which actually turns it into light pulses or radio waves. Then, when it arrives, the whole process just happens in reverse to unpack it. So now, these new response packets, filled with the video data you asked for, they begin their journey back to you. And fun fact, they might not even take the same path they used to get there. But they eventually find their way back to your router, which sends them to your device. Your browser then puts all those little pieces back together in the right order, and bam, the video you wanted to watch starts streaming on your screen. So we've just followed this epic, lightning-fast journey. And while it's definitely cool technical trivia, why should you actually care? Why does understanding this invisible process really matter? Well, knowing this stuff is actually super empowering. The next time your internet is slow, you'll have a better idea if the problem is your Wi-Fi or something further down the line. You'll understand that latency, or lag in video games, is literally just the travel time for these packets. And you'll see exactly why things like firewalls and VPNs are so important, because they're designed specifically to protect and alter this very journey. And seriously, don't just take my word for it. You can see this for yourself right now. Just open up a terminal or command prompt on your computer and type traceroute google.com or tracert if you're on Windows. You will see step by step every single router your data passes through on its way to Google. You're literally watching the journey unfold.
At the end of the day, the internet isn't some abstract cloud. It's not magic. It's a real physical system that follows a clear, logical process. And when you truly understand the path your data takes, something like cybersecurity stops being this fuzzy, abstract concept. It becomes a very real, very tangible mission, a mission to protect the journey.